Good morning, this is Mr. Precella, and I'm going to work a problem involving the sum and difference identities for tangent. I worked one similar to this in class yesterday, but before I do, I want to review rationalizing binomial denominators. Most of y'all remember right offhand how to rationalize a denominator if it's just one square root, one term in the bottom. If you have something like 1 over the square root of 2, to rationalize it, you just multiply above and below by that one square root. So you get square root of 2 over the square root of 4, which is 2. What's wrong with my pen? But if there's two terms in the denominator, then it's a little bit more involved. Let's suppose just we had 7. All of my pens are dry, it seems like. I guess because it's so cold in this room. If we had the fraction 7 over 3 minus the square root of 2, you don't just multiply above and below by square root of 2, because if you did, it wouldn't completely get rid of the square root. Imagine multiplying above and below by just square root of 2. You'd have 7 square root of 2 on top, but on the bottom you'd have a 3 square root of 2 minus 2. So in a previous algebra class, and it may have been a while, you may think, oh, I don't remember seeing this, but yeah, you did. You just forgot it. It's been a while. To rationalize a denominator when there's two terms down there, you multiply above and below by the conjugate of the denominator, which would be 3, change the middle sign, square root of 2. So what I'm doing right here is multiplying above and below by what's called the conjugate of the denominator. And look what happens when we multiply that out. Up on top, we'd have 7 times 3, so 21 plus 7 square root of 2. And on the bottom, when we FOIL that out, 3 times 3, 9. Then a plus 3 square root of 2, that's first, outer, inner, and then negative square root of 2 times negative square root of 2 is just a minus square root of 4, which is 2. So, the 3 square root of 2 subtract out. We no longer have any square roots in the bottom. So yes, we've rationalized it. We've rationalized that denominator. And we'd have 21 plus 7 square root of 2 on the top. And the 9 minus 2 is 7. You know what? Would have been smarter of me not to bother distributing the 7, because I'm about to undo that. If I separate each one of these, that 7 will cancel. 21 divided by 7 is 3. 7 square root of 2 over 7 is just square root of 2. Okay, so we did a problem like this in class, in my face-to-face class the other day, and so I just thought I'd do another one. Now let's get to, remember, if there's two terms in the bottom, to rationalize, you change the middle sign and multiply above and below by that. They don't all simplify so nicely as this one. I was just lucky in the one I made up. Okay? Now, let's look at the problem we're going to do. Find tangent s plus t, given that sine s is 1/4 with s in quadrant 2, and sine t is negative 1/2 with t in quadrant 4. And maybe I need to zoom in a little. Let me move it a little closer. I'm doing an old physical zoom. And let me just make sure everything's focused. Can y'all see it better than in the back? So let's see. Let me write down the problem. I'll color code it as I write it down. Sine S is 1/4, and S is in quadrant 2. Sine T is a -1/2, and T is in quadrant 4. Some of y'all would probably, find cosine using the Pythagorean identity, but I think what I'm going to do instead is use the XYR definition. If you're watching this and you're in my face-to-face class, that's how I normally do it, face-to-face class. But in the online classes, if you're just a view and example person, probably in the view and example they would say sine square S plus cosine square S equals 1 and find cosine. But what I do is just XYR, that first definition that we used for the 6 trig functions. I'm going to set it up for both of these, X, Y, and R. But let me make sure now, let's go ahead and take care of those quadrants. We're told that S is in quadrant 2, and so that means in quadrant 2, X is negative and Y is positive. Can y'all tell my green? The quadrant 2 I used right here to decide between these signs on X and Y, these SIGN signs. Okay? Now, over here we're in quadrant 4, and so in quadrant 4, X is positive, Y is negative. So let me work with S. Sine is Y over R, so a positive 1 over R. X squared plus Y squared is R squared, so X squared plus 1 squared is 1. 4 squared is 16, so I'll subtract the 1 and get a 15. In algebra, we would say X is plus or minus the square root of 15, but not here. Here we know X has to be negative. That's where that quadrant 2 comes in. In quadrant 2, X is negative, Y is positive. That's why I'm choosing a negative square root of 15 rather than positive. Now, coming over here, doing the same thing for T. Sine is Y over R. Well, R is always positive, so R is the 2. Y has to be the negative 1. And we knew Y should be negative, and it is. X squared plus Y squared is R squared. So X squared plus negative 1 times negative 1 is just a 1. 2 times 2, 4. So we have X squared equals 3. So X would be, in this case, the positive square root of 3. And we knew it had to be positive, not negative, because we're in quadrant 4. So now let's find, what do we have to find? Oh, tangent S plus T. So tangent S plus T. Let's write these little identities. It's tangent S, same symbol, tangent T over 1, change the symbol tangent S times tangent T. So we're going to need to know tangent S and tangent T. So let me go ahead and write those out. Okay? Remember, it's the same symbol as in the parentheses on top, and then you change the symbol on the bottom. The way you can remember same over change is the way tangent is sine over cosine. S over C. Sine over cosine is tangent. Same symbol, change the symbol. So let me go ahead and write out tangent S. That's in blue. In terms of x, y, and r, tangent is y over r. So we have 1 over the negative square root of 15, which I'll just write as negative 1 over the square root of 15. Got to rationalize, but this is an easy rationalize. Multiply above and below by square root of 15. So we'd have negative square root of 15 all over 15. So there's tangent S. Now, what about tangent T? Ooh, I need to lift this up, don't I? Okay, so tangent T, tangent is y over x, so negative 1 over the square root of 3. I'll rationalize. These are the easy rationalizing, aren't they? Negative square root of 3 over 3. And now let's start plugging in here. In place of tangent S, I'll put negative square root of 15 over 15. In place of tangent T, I'll put negative square root of 3 over 3. So we have plugging in up there. So right here, I guess I don't need any of that. Let me lift it up some. So it's tangent S, negative square root of 15 over 15 plus tangent T, negative square root of 3 over 3 all over 1 minus tangent S, oops, S is blue, negative square root of 15 over 15 times tangent T, negative square root of 3 over 3. Oh gosh, so maybe it'd be better to write this all in just one color. Negative square root of 15 over 15. I'll go ahead and just write minus, plus a negative is just a minus. And then 1. Now we have a minus, then a negative times a negative. So that negative times negative is going to be a positive. Now to multiply these, you just multiply that top. Square root of 15 times square root of 3 would be square root of 45 all over 45. Now, I'm thinking we could simplify the square root of 45. Okay? We could either do that right now, or maybe it would look better if we just went ahead and reduced this compound fraction. Notice how we have 3 denominators within the fraction. So if I multiply above and below this fraction bar, multiplying by 15 would cancel out this one, but it wouldn't I guess it cancel out this one too, but it wouldn't cancel out that. I would need to multiply above and below by 45. If I multiply above and below by 45, what would happen there? So I'm distributing this 45, and it's going to start looking a little bit better in a moment. Distributing the 45, we would have 45 times the negative square root of 15. We'll just write that as negative 45 square root of 15. Negative times what am I doing there? I'm looking at stuff out in the hall instead of paying attention to what I'm doing. Okay, here. 15 goes into 45 3 times. 3 times negative square root of 15 would be a negative 3 square root of 15. Do y'all see how I cancel that? 45 over 1 times negative square root of 15 over 15. Cross canceling. 15 goes into 45 3 times. 3 times negative 15 is negative 3 square root of 15. Doing the same thing here. 3 goes into 45 15 times the square root of 3. At least we no longer have fractions on top. And what do we have on the bottom? We would have 45 minus, here the 45's cross cancel completely, and we're left with just the square root of 45, which I'm going to go ahead and simplify that square root before I have to rationalize. Now let's look at what the answer choices are going to look like. There's no square roots in the bottom. Okay, so let's simplify that square root of 45. I'm going to do that right out here. The way some of you might use factor trees, but if the numbers aren't real large, the way I simplify a square root when it's not a perfect square is to rewrite it as a product. Product means multiplication. If we had 45, we could think of that as 9 times 5. Why am I using a 9 and 5, not a 3 and 15? Well, it's got to be a number whose square root you know, and you know the square root of 9. So that would simplify to 3 square root of 5. Okay. So let me just get another sheet of paper. I'm running out of room. We're now about to start doing the stuff that I was doing at the beginning, the rationalizing a denominator when there's 2 terms, except it's going to be a little bit messier than, this one here. Rationalizing denominator when there's 2 terms. This one's going to be a little bit messier now. Let me write down the problem. Negative 3 square root of 15 minus 15 square root of 3 all over 45 minus, replacing the square root of 45 with 3 square root of 5. And now I'm about to start rationalizing. To rationalize a denominator when there's 2 terms in the bottom, you multiply above and below by the conjugate of the denominator, 45 plus 3 square root of 5. This is going to be a really big fraction. Okay, so falling out the top. Negative 3 square root of 15 times 45. 45 times 3, what would that be? 120 plus 15. So we have a negative 135 square root of 15 first. Then an outer. 3 times 3, 9. 15 times 5, is that a 75? I think I'm going to be able to simplify that some. Inner 15 times 45. Well, positive times negative is negative, and we have a negative 675 square root of 3. And negative times positive is negative. Is that going to be 45 square root of 15? Now, falling out the bottom. 45 times 45. 2025. That's first. Now, fortunately, the outer and inner terms are about to subtract out. Whenever you multiply a minus b times a plus b, you just get a squared minus b squared, that difference of squares. So 2025, I'll go ahead and show it. The plus 135 square root of 5 and the minus 135 square root of 5. And then what are we going to have here? Negative times positive is negative. 3 times 3, 9. Square root of 5 times square root of 5 is square root of 25, which is 5. So 9 times 5, just a 45. So this is subtracting out. Up here, the only square root that can't be simplified, that can be simplified, is the square root of 75. So the way I'm going to do it is what I did over here. Rewrite the number as a product, like I did with 45. I went 9 times 5. Well, with 75, I'm going to write that as 25 times 3. Ooh, can y'all see that invisible 25 there? That's orange ink isn't showing too good. And then the square root of 25 is 5. So we have 5 square root of 3 times this 9. So I'm going to rewrite the whole problem. Negative 135 square root of 15 minus 45 square root of 3. Do y'all see where I'm getting that 45 from the square, rewriting 75 is 25 times 3. The square root of 25 is 5. 9 times 5, 45. Then we have a minus 675 square root of 3 and a minus 45 square root of 15. Now what about on the bottom? 2025 minus 45 is 1980. Oh wow, I remember that year. Let's see. Now, let's combine the like terms on top. 20 short years, we'll be through with this, don't worry. Let's see, there's a square root of 15 here and here. So negative 135 plus a negative plus a negative 45. Is that going to be a negative 180 square root of 15? When you're combining square roots, remember, you're just adding the numbers. Don't add the 15s. And so that does negative 135 plus a negative 45. Now let's do the square root of 3's. Negative 45 plus a negative 675. Is that a negative 720? Over the, negative 720 square root of 3. Still all over that 1980. So that's not one of the answer choices. If y'all forgot what the answer choices were, they look like, ooh, let me pull this down. Here are the answer choices. So either we're going to have an 8 or an 11 in these. So it's a matter of reducing this fraction some. So it's a matter of how long you can figure out what number divides into these three numbers that are not under the square root. Negative 180, 180, 720, and 1980. Well, if you need some hints, you might divide 1980 by 11 or by 8. 1980 divided by 8, nope, 8 doesn't go into 1980. But if you divide all three of these by 180, or sometimes students like to write it by factoring out and then canceling, a fast and dirty way to do it is just say, okay, I'm going to divide these three numbers here by 180. Negative 180 over 180 is a negative 1 square root of 15. Negative 720 divided by 180 is 720 divided by 180. Am I doing this right in my head? I'm getting a 4. Someone punch in 720 divided by 180 in your calculator if you doubt it. Okay. All over 180 divided by, 1980 divided by 180 is 11. So I guess I wrote this 1. I didn't really need it. I would have, if I just want to write negative square root of 15 minus 4 square root of 3 all over 11. Okay. Oh, let's make sure that that's one of the answer choices. Let's see. There. Let's see. Negative square root of 15 minus 4 square root of 11. Well, they wrote it as negative 4 square root of 3 minus square root of 15. I think I said square root of 11. I meant 3. So I'm thinking the answer is B. Notice they wrote the negative 4 square root of 3 first, and then the minus square root of 15 all over 11. Okay? So this one was a little bit more involved. Yesterday, I think my students sort of agreed, yeah, this is one of the longer problems we've done this semester. Okay? To which I told them, well, just wait. They're all going to be like this from now on. I didn't really. That's not true. Okay, so, oh, wow. There it is, all worked out. Okay. Okay. Well, I hope to see you in class soon, and I will go on and teach another class now. So thank you for watching. Bye-bye.